Yeah, and there is an advantage, of course, due to cost saving, that also existing solutions will get pressure in order to lower their price. Another clear expectation was also formulated, and this is already mentioned in the previous sessions as well: cost saving. It's perceived that the total saving of cost is in the range of system development cost is in the range of 25 to 30% of this system development cost. And the calculation is done in a way that roughly 50 to 60% is seen to be spent for software development. The rest is system validation, hardware development, system integration. Now let's go for that. I strongly believe that this is true. How the logic and how the thinking is, how you can exactly come to this result that you save cost with Linux-based RVI development. So the benefit of Linux is reuse, and let's start from there. This is exactly the logic of the calculation of the cost. You have the total development cost for a device, including hardware, including software, system integration, and system validation. And GENIVI just focuses first on the software development. And this RVI software stack is basically divided in 4 main parts: operating system, middleware, application framework, and human-machine interface. Now, when starting on a real-time operating system-based development, RVI solution, you purchase an operating system, including the BSP for the specific hardware. All the rest is productization effort. So customized RVI middleware, application including framework, HMI, to be done by the developer itself. And the traditional business model is that there is one tier 1 supplier choosing, for example, QNX, the other one choosing MicroItron, and even when they choose the same operating system, they do it in parallel and have the complete productization effort in parallel. And this is quite when BMW did a re-engineering of their RVI systems, and their RVI systems today have round about a memory use of 1 gigabyte, in the range of 1 gigabyte. And guess what? You give memory to a software developer, he will use it completely. And this complexity is even exploding. The speed of increase of memory in the RVI systems is basically the same steepness as you have in the PC industry. It's just a delay of a couple of years. So software complexity needs to be managed. On the other side, when we go to a GENIVI-based solution, GENIVI is really focusing on the platform, on the middleware. And the reason why they're going from bottom up is that this middleware is containing non-differentiating features. Features you need to have in each and every car, independent whether it's a Toyota car, whether it's an RVI system for a Honda, or whether it's an RVI system for a Nissan. Now, the good thing is that the customization, which is here 100% of the middleware, is going to be reduced. Therefore, the productization effort in total will be reduced. And the summary is that for sure, the expected cost saving applying with the GENIVI, when you apply a GENIVI-based stack, will be in the range, and this is our calculation as well, of 40-50% of the total RVI software development, which then ends up when you think that 50% in addition to that is system development, that you have this expected decrease. So we think this is pretty much true. Now coming to the other benefits of open source development. We talked a lot about MeeGo, MeeGo stack, MeeGo benefits. When we created last January we launched the first GENIVI reference. It was based on Moblin. It's the predecessor of MeeGo and is now ported to MeeGo. The GENIVI platform is exactly the middleware stack, so where all the non-differentiating features is. When you analyze this stack, it's very interesting that 80% of this stack is used and reused one by one, coming from the open source industry. It's really open source code and not adapted at all. The rest, the 20%, out of the 20%, 15 are adapted, so specifically configured that you fulfill the automotive needs. Think of an audio manager, which is very much specific. You have already an audio manager in the open source world, but you need to adapt it to specific needs. Persistency manager is another thing, or startup behavior, run-up, startup. Just 5% of the stack is really new created code. And this is very specific code in order to connect to other interfaces in the car. For example, MOS interface, or when you have to have an AUTOSAR compliant diagnostics interface. There you need to create specific code, of course. This is not available in open source. Very specific to automotive. In addition to that, what is the target for a reference application? You want to show innovation. And this is already, I mentioned it already, one reason why MeeGo, or before that Moblin, was chosen. There is an application framework available which provides the capability of showing immediately in a demonstrator then the innovation which is out there in the market. On the other side, what is the difference when you go to a GENIVI-based product? The target of the reference implementation is really to show innovation. Each and every new technology needs to be integrated and shown immediately as application so that you can demonstrate it to your customer or to your management or whatever. Here in the product development, there are some specific needs, and you will see then in one of the next slides. You need to optimize it to very, very specific needs. The configuration set is normally already given. So you need to take care about performance, memory footprint, and so ever. And you need to optimize it to specific hardware needs, depending what hardware your customer is basing his system on. So the question here is really, in the previous slide, why do you need companies like Wind River, operating system vendors, or Monta Vista in order to do this? Because this is already an open source there. One of the needs is really the optimization of the code, the optimization also in terms of footprint, not only in terms of performance. And the other one is basically to adapt to the embedded terms and conditions. And this is very specific true for the automotive industry. And just focus here first on the bottom line. You are out from the industry, you are aware of the various milestones. You call it A sample, B sample, C sample with 100% feature complete. And here's start of production. So the car with the new developed infotainment system is launched and is going to go out on the road. And then with several upgrades and maintenance. You are completely familiar with the R&D, with the life cycles, independent whether it's the development life cycle, the product life cycle, or the maintenance and support. And when you just end up the number of years, you immediately, when you take the maximum, which is very, at the moment, the real world, you're in the 25-year range, 23, 25-year range. This is the time span where technology needs to be maintained and a service needs to be provided for at the moment. For sure, due to the very rapidly innovation in the consumer world, specifically the time to market, the development, and potentially also the production will be reduced. Nevertheless, you will have service and maintenance for a couple of years. Although it's a nice mobile device, a car, you don't throw it away after 1 year or after 2 years. So easy.